Hello class, today we're going to cover section 2 of chapter 2, and it's going to be all about physical properties. Now, just like previous chapter section where I split it into part 1 and part 2, we'll be doing the same thing with this section. So let's cover part 1 today. There's a scenario, and the scenario is there are pitchers of ice water and lemonade on a picnic table. So how do I know which one is the water and which one's the lemonade? And you might say, Miss Chastine, that's easy. Lemonade's going to be the yellow one, and if I were to drink it, it's going to have a taste. It might be a tart taste. If you add a lot of sugar, it might be a sweet taste. And you're going to be like, that's easy. Well, that description that you gave lemonade being yellow and the taste, these are considered properties. Now, we talked about properties in a different video, in a different lesson. These are things you can use to describe things. So we just did color and taste, but smell, sight, how much it weighs, all count as well. In fact, if we were to give properties to water, most of us will say that it's colorless. You can see through it, and that it has a very bland taste. It's not sweet, it's not sour, it tastes like water. So what is a physical property? Because that's what we're going to cover today, a certain type of property known as physical. Well, a physical property is any characteristic of a material that can be observed, which means you can look at it, or measure. So you can measure it with a balance, you can measure it with a ruler, and it doesn't change the composition. Now remember, composition was a key vocab word that we covered in the last section, and I said it's going to pop up a lot. So if you remember, composition is what it's made up of, so it's makeup. So a good example of a physical property is color. I can look at the color of water as clear, and it doesn't change what water is made up of. It's still going to be 2 hydrogen and 1 oxygen. So what are some examples of physical properties? There are a lot of examples of physical properties, including viscosity, conductivity, malleability, hardness, melting point, boiling point, and density. Now, I don't want to confuse you. These are not the only physical properties that there are. These are just common examples we use in science class. So I want to make sure that you understand what these words mean. So the first one we're going to cover is viscosity. Viscosity's definition is the tendency of a liquid to keep from flowing. So it doesn't want to flow. So anything that is a thick liquid, some examples are corn syrup and honey, these have a high viscosity, which means they flow slow. Well, cannot spell slow, slowly. Let's rewrite that. That looks sloppy. Slowly. Things like syrup for your pancakes. You're going to notice that when you tip that bottle upside down, it doesn't just run out as fast as it can. It kind of flows down the edge of the container and slowly goes on your pancakes. While thin liquids such as vinegar and water have low viscosity, or I like to say they flow fast. If you were to tip a cup, that water is going to flow very easily and fall out of your cup real fast. The next one is conductivity. So this is the material's ability to allow heat to flow. Materials that have a high conductivity are things like metals. The ability to allow heat to flow is actually very important, especially when we talk about cookware. If you have a metal spoon and you're cooking and you leave that metal spoon in like a pot of boiling water, since it's metal and it is a good conductor, that heat from the water is actually going to travel up that metal spoon all the way to the handle. So if you touch a metal handle on that spoon, you're going to burn yourself. However, wood, it's not a metal, so when you put it in a pot of boiling hot water, the heat is not going to travel up that wood as easily. Now, if they're a good conductor of heat, usually they're also good conductors of electricity. So we use a lot of metal wires to send an electric current to different parts of our house to light it up. If you've ever heard of copper wiring, or even the wires inside your phone charger or your computer charger, all of those have metals in those wires that are good conductors. The next physical property is malleability. So this is defined as the ability of a solid to be hammered and it doesn't shatter. So again, a lot of metals are malleable. You can hit it with the hammer. It might bend, but it doesn't shatter. Unlike an ice cube or a piece of glass, I'm going to tell you, if you go up to your window and you hit it with a hammer, it's going to shatter into a bunch of tiny pieces. So this is considered brittle and it's not malleable. Hardness is our next one. It is defined as one material can scratch another material if it is harder than the other material. A good example of this is if you had a kitchen knife and a copper sheet, because there might be some cooking sheets that are made up of copper, and say you're cutting on that cooking sheet. Well, that kitchen knife is made up of stainless steel, and in fact, if you scratch it against copper, it's going to scratch it. And that is because stainless steel is harder, remember hardness, than copper. Now, that doesn't mean a kitchen knife can't be scratched. In fact, if I wanted to scratch stainless steel, I just have to choose something else that is stronger or harder than it. So diamond is actually our hardest known material. I bought my fiance a ring made up of tungsten. Tungsten's an element. And tungsten's very, very, very hard. But when his ring came in, it came with a little note telling it, don't put it near diamond rings, because diamond rings are the only thing that's going to scratch it. The next two are melting and boiling points. So temperature actually can also count as a physical property, how hot or cold something is. And the temperature at which materials can change state is important as well. Now, if you don't know what state is, let's actually review that. State of matter is like if it's a solid, liquid, or gas. Those are the three states of matter. So here, the first one we're going to talk about is melting point. Whenever something turns from a solid to a liquid, it's said to melt, and that's known as the melting point. So when water turns from ice to liquid water, it usually does that above 0 degrees Celsius. So 0 degrees Celsius is a melting point. The temperature at which a substance changes from a liquid to a gas is known as the boiling point. Think of water. If you have a pot of water and you boil it, that water rises as steam or water vapor. So that's the boiling point. And the last physical property that we're going to talk about is density. Density is the ratio of the mass to its volume. You've seen this definition before when we covered section 1 with SI units. So ratio, it means to divide. So we're going to divide mass divided by volume to get density. Density is actually an important property because it helps you test the purity of a substance. So how pure of a substance do you have? Silver has a density of 10.5 grams per centimeter cubed. If you were said that you had a coin and it was pure silver, it would have to have a density of 10.5. If it had a density of 9.9, we know that is not made of pure silver, or it has something else in it with that silver that makes it impure. Now that we've learned about all of these physical properties, how can knowing about them be useful? So physical properties are actually used to identify a material. So if you have an unknown in front of you, you can perform a series of tests on it to figure out what you have. You can also use properties to choose a material for a purpose. If you want something that's hard and durable, you might look at the physical property hardness. Or you can use the physical properties to separate a substance or separate things. We're going to look at that in the next section in part 2 of this video, so you'll learn about it tomorrow. So let's walk through each of those three things. Using properties to identify materials. So a material can be identified by its properties, kind of like we did in that opening question with lemonade and water. We looked at lemonade and water's color, and that told us which one was which. So the first thing you're going to do is decide which properties to test. Are you testing color, hardness, boiling point? Then what you're going to do is you're going to do tests on that unknown material. And then what you're going to do is you're going to compare what you got for your results based on known data. And then you're going to make an educated guess of what you think that is going to be. The next one is using properties to choose materials. So properties determine which materials are chosen for which uses. If you were trying to find shoelaces, you want them to be flexible because you want to be able to tie them, so you must be able to bend them without breaking and tie them into a nice little bow. But you also want them to be durable. That means you don't want them to fall apart after wearing your shoe one time. You want to be able to wear your shoes over and over and over again. Repeated use. So here's a good picture. This is a hiking boot, and here are the laces. The laces on hiking boots, we usually use nylon or leather because, like I said, they're flexible and they're durable. We're not going to use wood, and that's because wood is too stiff and it will break if you try to bend it. We're going to end this section on recognizing physical changes. We've been talking about physical properties. Physical changes are when those properties change, but the material remains the same, or it has the same composition. So a change of water from a liquid to a gas is physical because water as a liquid is H2O, and when you boil it to become a gas, it still has the composition of 2 hydrogen, 1 oxygen. So during a physical change, the size can change. So for example, you can cut a paper in half. It's still paper. And the shape can change. So maybe I Play-Doh into a ball. So there I'm changing shape. But again, my composition does not change. It's still Play-Doh. So other examples are melting butter in a pan. If I melt butter, it's still butter. If you crumple a piece of paper, that just changes the shape. It's still paper. Slicing a tomato changes its size and shape, but it's still going to be a tomato. Also, changes in state, so solid, liquid, gas, are always going to be physical changes in any change in size. Now, some physical changes can be reversed, but not all of them. So braiding hair is considered a reversible change because if you braid hair, you can always unbraid it and it goes back to normal. However, if you cut hair, I'm sorry, but you're not going to put that hair back exactly how it was. If you get a bad haircut, unfortunately, you either have to wait till your hair grows out or get a different haircut to fix it. So cutting hair is not reversible or cannot be reversed. And that's the end of your lesson. If you were confused on anything or you had any questions, please let me know, and I hope you guys have a good day.